Hello, this is Bryant Meyers, and welcome to another edition of Debunking Flat Earth. As we begin this video, in the background, you're going to see some beautiful images from the Himawari-8. And this video is a response to Jeranism and Globebusters' attempt to debunk my last Himawari-8 video. Now, the Himawari-8 is destroying flat Earth every 10 minutes. So, of course, they're going to try to keep responding to what I'm sharing. But as we'll see, just as before, as this is now their second attempt to debunk on my Himawari videos, they did not even cover all the main points. But we're going to go through what they did cover, and we're going to just rebuttal and debunk all of them. So just to recap, Himawari-8 is giving us 11K by 11K images 142 times a day. And these are just massive, beautiful images of the whole disk of the Earth. And they come from the advanced Himawari imager that uses 16 different spectral bands to give many different photos and many different spectral frequency bands that are then combined into different composites for meteorology and weather forecasting purposes. So while it is a weather satellite and it's not really designed to prove the Earth is a sphere, which we've known for 2,500 years, it does give us whole disk images 142 times a day. So it really does debunk the flat Earth, which is why they need to respond, because this is a dagger in their whole model. Because they don't have any whole flat Earth images, they just have those cherry-picked, ridiculous, level horizon that comes from a fisheye lens. And if you watch the video footage, you'll see the horizon go up and down like this, and they pick the point where it's flat. So really, they have no whole flat Earth image from space, and they're happy to admit that even. And we literally have hundreds of thousands, especially for Artemis now, of whole Earth images from space. And I've done several videos on these Artemis images confirming their validity. And I'll put a few links below this video because it's just more convincing evidence that we live on a sphere. So Jaron and I have kind of been having it out a little bit through email here. And he thinks that I should apologize to Paul on the plane because I said the images are not brought to us by the NOAA, meaning the Himawari images are not brought to us by the NOAA. So what does Jaron do? He totally takes it out of context, does this whole little short on TikTok, and of course they make a big deal out of it. They spend a lot just over this one little thing. They spend so much time during their roundtable. It's just ridiculous. And let me just show you here, because if anything, Jaron and Paul on the plane should be apologizing to their audience, because Paul on the plane is the one that's misleading people. And let me just play again.
Let's cut right to the smoking gun to start. Here is the website anyone can go to and see this all for themselves. On a side note, the Himawari is operated by the Japanese Meteorological Space Agency and brought to us by the NOAA, the National Oceanic and Atmospheric Administration's GOES geostationary satellite server.
Okay, so all of this was around just that one thing, and here's what Jaron was doing. So basically, I read right here, these images are updated every hour from data provided by the Japan Meteorological Agency and brought to you by the National Oceanic and Atmospheric Administration, NOAA. So here's how Paul on the plane is saying that the NOAA is bringing us Himawari images. So it's basically like 4 steps of what Paul is saying if you watch this little 7-minute video. Step 1 is that these images are going to give us cloud cover over the oceans, because Doppler radar, and it's true, that can't cover the cloud cover over the oceans. And what Paul says is that these images, which are on the FTP server, and for some reason there's a whole, I went through this in my last video, so definitely watch my last video as a reference. But he just kind of randomly picks one of these folders. These are just annual temperature predictions, nothing to do with cloud cover at all. But what he's saying is that the NOAA is bringing us, these Himawari images by, first of all, taking these annual temperature maps and then using supercomputers to somehow create cloud cover over the oceans. And then he says that Doppler radar gives us cloud cover over land. And he didn't answer any of these points. The only thing he answered was the Doppler part of it. But he did not address the annual temperature variations. He did not address the air mass imagery and the terminator line. And this was what Paul was saying was what's wrapped around a ball. And this is what, the NOAA kind of spoon feeds us, for Himawari images. This is why it's not brought to us by the NOAA, Jaron, because this is not how it's done. This is all a lie. So when I said, no, Paul, this is not brought to you by the NOAA, what I meant was this reasoning that you have is not how it's done. The Japan Meteorological Agency is separate from NOAA. They're different countries and different agencies. And just because the NOAA has backup servers where they store Himawari images does not mean that they're making these the way you say they are. So you can kind of see so basically these emails that I'm emailing Jaron here, I'm going through these points, and he really has no answer. He says, well, we addressed that. But I kept pinning him down. I said, no, you actually didn't, Jaron. You did not cover how temperature maps can give us cloud cover, which is what Paul says. You didn't cover that at all. And the whole thing with simulation, which I talked about in my last video, is that the simulations actually depend on satellite data. Again, it doesn't help your cause to bring in simulations here because they're using satellite data, as I showed in my last video. There is no way you can get cloud cover from annual temperature prediction maps. These are just predictions. They're not meant to be even set in stone, even for temperatures. But nothing to do with cloud cover at all. So then I said, Jaron, you also didn't explain the whole air mass imagery. So it was really funny because when they were playing back my video, they went through the air mass imagery and the Terminator line thing, which I totally destroyed in the last video. And they didn't even comment on it. They just went on to the next point. And Jaron's like, no, we addressed that. And I said, give me a timestamp, Jaron, of when you addressed that. And guess what? He didn't give me a timestamp. He just asked me what the frequencies that are used for the Terminator line versus what the cloud cover, how you get cloud cover with infrared cameras. And then I answered him and he didn't email me back. So he doesn't have an answer. So and the reason Jaron doesn't have an answer here for the air mass imagery is that this is just one of 20 different composites that the Himawari, that the JMA is doing with all these different 16 spectral bands. And the air mass imagery is kind of like a water droplet kind of precipitation type of map. And it gives meteorologists and weather agencies a lot of good information. But what Paul is saying is that somehow Doppler radar over the land and annual temperature maps along with computer simulations give us this image here. This is what Paul says, that this is the composite that comes from this simulations and the Doppler and the annual temperature maps. And they wrap it around a ball, and this is what is spoon-fed to us, to use Paul's words exactly. I've watched that video so many times, I know his whole script. And somehow, and then they paint a Terminator line on it, and this is what we're given. This is what we're spoon-fed. The Terminator line, down here. So Jaron had no answer at all. Just crickets. I mean, and again, he's not going to be able to have an answer because anybody can easily see. If you look at, and I even put the document on my last video, the link to my last video, to where Himawari has a whole document where they go through these different composites, and air mass RGB is just one of 20. So for some reason, Paul just randomly picks this one out, and then Jaron's like, well, he did say he randomly picked it out. It's like, no, Jaron, that was when he was already in the folder. He randomly picked one of the air mass imagery photos. Again, Jaron, watch it again, because you did say randomly, as if he's randomly picking one of these. No, he's not. He's targeting the air mass imagery and saying that this is somehow how all these Doppler and simulations are put together, and somehow then this is transformed by CGI or whatever into this image that we're spoon-fed, and they paint a Terminator line on it. So basically, everything that Paul says is wrong. The last thing he says is, what camera does a Terminator line then come from? And so I explained to him, obviously, it's very clear they don't understand how infrared cameras work. Because in my last video, I showed the research study showing how infrareds can image clouds. And again, they didn't even respond to that part of the video. They just went right over the top of it. So 3 out of 4 of Paul's points, they did not even touch. They didn't even touch him. So he's wanting me to apologize to Paul? They don't have an answer for Himawari because it destroys their model. And I'll keep responding, guys, because I'm not going to relent on Himawari. Himawari destroys the flat Earth 142 times a day. Like this is a particular example here, and you can see the timestamp is every 10 minutes. Look at, it just keeps going. 9:10, 9:20, 9:30, 9:40, 9:50. It just goes every 10 minutes. And again, these are just such detailed images, 11K by 11K. You can really zoom in on these. Let me get one of the whole Earth here. I mean, you can see, look, it's just amazing detail. So, again, you can't get this kind of cloud cover detail from Doppler, guys. And you certainly can't get it from temperature forecast maps over the ocean along with supercomputers. And again, as I talked about in my last video, even the very best supercomputer simulations, which do look pretty good, but they're not exact, they rely on satellite input. Again, doesn't help your case when satellites are feeding into the simulations. So one of the things that they talk about is the base maps, and they really don't understand how a base map works. So for the GOES 1617, they use the Blue Marble dataset next generation. But they don't always use the Blue Marble dataset as a base map. In fact, it says right here in this PowerPoint presentation from Colorado State that the true imagery, daytime images, there is no base map used when you just see those beautiful images of the Earth. Now, if you want to add continents to overlay on that, then yes, you're invoking a base map. But the images themselves, as you're looking at that, doesn't have a base map. But there's nothing wrong with using a base map. It just helps to orient the image so that it's in the right place and that you have a geographical markers and scales that you can see the different countries and borders and states, etc. They're still real images. And Himawari-8 also uses a base map for the nighttime images because, again, they're using infrared cameras for cloud cover, so they do need a base map to line up, the clouds with the right location on the Earth. This is just standard practice. There's nothing wrong with doing that. I mean, these are still real images, but like the GOES 1617, the Himawari-8 does not use a base map for their daytime images, like the images we were showing right here. So yeah, these whole Earth images, there's no base map here. And as I was trying to explain to Jaron, the infrared, the cloud cover, and again, there is a base map in the background here because this is a nighttime image. So if you want to see where these clouds are at night and you want to know where they are, yeah, it's nice to know, where the countries are so you can see the clouds over your area. Otherwise, everything's just going to be in the dark here. If you're just going to see clouds over the dark, you're not going to be able to know where those clouds are. So of course you're going to use a base map at night. Because if we just use a true image at night, it's just going to be totally black because it's night. I mean, come on, guys, this is not hard to understand. Let's talk about radar now because they're kind of really aggressively trying to defend Paul on the radar. I mean, at least they address one of Paul's points with the radar over the land. So let's look at that. So there are limits to radar now, and again, even millimeter wave radar, even if it gives you more accurate cloud cover, it's got a much shorter range. And it's not going to give you, again, these different bandwidths that they use will image different layers of the clouds. So millimeter alone is not going to be a cloud cover. I mean, you've got to use all these different frequency bands, and they do their best to get, and they're getting better. I mean, give them credit. I mean, the Doppler systems are getting better and better. But they can't give you the type of cloud cover that you can see from Himawari, just absolutely not. And here's some other problems. And again, radar, if any flat earther will pick up these radar manuals, it doesn't really help their case because they talk a lot about Earth curvature, and you can't see, and the reason why you can't see it past a certain range is because of the curvature of it. So actually, the radar systems, if you're going to really stick to your guns, guys, and say that radar gives you cloud cover, then you're going to have to use these radar manuals that show how Earth curvature plays into it. So again, Earth curvature validated once again, and flat earthers debunking themselves with their proof. And so again, the wavelengths penetrates so here's the problem with millimeter wave radar. The wavelength will limit the penetration. So you can get better detail with millimeter wave radar around the edges, but it won't go into the core. So you got to use like longer wavelengths. And again, they're getting better and better, but they're not giving you anything that like Himawari and the satellites can give. They just can't do that. And there's other problems too. So let's look at this. I'm going to put a link below if you really want to, and I highly recommend Jeranism and Globebusters read this to learn more about radar and the limitations of radar. And let's just jump right to the limitations here. So the first is the range. And again, let me just highlight this here. The limitation of the range of radar is due to the curvature of the Earth, guys. So if you really want to stick to radar, you're going to have to acknowledge that the Earth has curvature. False readings can happen where, because again, different densities of rain, you can't always get an accurate map, because if the densities are different, certain wavelengths are more accurate than others for different densities of the rain. And a very fine mist of rain can sometimes be missed totally with radar. But these type of things are not going to be missed by actual, the actual visual bands coming from satellites. So the last thing is that the echoes. So a weather radar can't detect echoes that are close to or above the radar. So there's basically these cones of silence with radar systems. There's no cone of silence from Himawari. When we're imaging the whole cloud, there's no gaps anywhere. It's very detailed. So the bottom line is, as I said in my last two videos, you cannot get accurate cloud cover from radar. That Doppler is not giving you the real detail. Again, here, this type of detailed cloud cover, very detailed, guys. I'm not talking about what Doppler is giving. I'm talking about actual, real, detailed cloud cover. This right here, you cannot get from Doppler. You did use the millimeter wave citation last time, but I just showed you how millimeter waves cannot do this. Millimeter waves can't penetrate to the middle of the cloud, and they have a limited range, and they got a cone of silence, and they got false readings that can happen, all these types of problems. I mean, I'm not saying that Doppler systems don't give meteorologists good data. They do. What I'm saying is that Doppler will never give you this very detailed cloud cover that you can only see from above with satellites or the stratolight balloons, which we'll look at as a possibility. But it's got to come from above. It can't come from Doppler. So Paul is wrong here. This is debunked. And again, just to emphasize before we move on here, even with the millimeter wave radar, I mean, the curvature of the Earth comes into play. So you guys have to address that. Why do all these radar manuals talk about the curvature of the Earth? So even in the best case scenario with the millimeter wave radar and using the best radar technologies, you still have problems with curvature of the Earth. You still have problems with cone of silence. You still have problems with different penetrations and error readings and false positives based on the precipitation density. So there's definitely problems with millimeter radar that's not going to give you the consistent type of images that you get every 10 minutes from Himawari. So let's now talk about a few things that radar absolutely cannot detect. So I just want to go over a few examples of things that you could never get from Doppler. And a really good example is actually a very recent volcanic eruption. And I want to show you this footage here that was actually captured by both Himawari and Goes West. And it was in this little island of Tonga, which is southwest. It's going towards us. It's basically going from Hawaii towards Australia. And there's actually many ways that this validated the globe. First of all, this type of stuff, it just happens so suddenly. You're not going to be able to pick this up on Doppler like Himawari and Goes is able to do. And an interesting thing about this, when this happened, is that this island itself is a very remote island, and it was offline for a couple weeks. So there was no Doppler, or there was no stations there that were able to image anything. But yet Himawari still imaged that. So this is just such a great validation and proof that we live on a globe. And the way that the pressure waves, okay, this is another little side note, the pressure waves from this volcanic eruption, I'm not a seismologist and I'm not going to pretend to understand the details, but I do know that these pressure waves, when they spread throughout the globe, they were detected, and there's a lot of geology that does validate the fact that we live on a sphere. So part of this is also a validation in that regard, but the image alone, there's no way this could have been taken in any other way except from a satellite. Just take a look at some of the footage here. I mean, it's devastating, but it's breathtaking as well. And here's one more example of volcanic eruption that took place several years ago, but just from Himawari, it was imaged in just another breathtaking image. Something else that these images that, Doppler and a lot of these systems can't do is capture the wildfires like this. And some of these images with bushfires in Australia and California with GOES, they were able to use the data from GOES and Himawari to help predict where the fires were going and to help locate them and track them. And it did help to save lives, so very valuable information. So another little proof that I like is these solar eclipses taken from Himawari and GOES. Again, just breathtaking images, and you're never going to get this from any type of Doppler or simulation. So the track of the eclipse here followed right where it was predicted. And as I showed in the last video, crepuscular shadows, you're never going to be able to image that with Doppler. So there's just some visual things that you're never going to see with Doppler. Another thing is like floods will happen. And Himawari and GOES can see the plains flooding. So now they went on and on a lot about balloons in this last video. And again, if they're trying to defend Paul on the plane never used balloons at all in his video. And I told Jaron, it's like, if you're going to call me a liar and you're trying to defend Paul on the plane, but now you're bringing up your own different theories and models, which is fine. But at least acknowledge that maybe Paul is wrong if you have to bring this stuff up. Because if Paul is so right about what he's talking about, then you don't even need to bring up balloons or other solutions. Do you at least understand that? So now I even told Jaron, I was like, Jaron, that's fine. If you guys don't agree with Paul on the plane, which I can see why, because it's a bunch of nonsense. If you want to come up with a better explanation, by all means, do so. So, okay, so that's fine. They can use balloons here. Let's kind of go through that. But just to be clear, Jaron, Paul did not talk about balloons at all in his video, and you're the one trying to defend him and me demanding an apology from me. So here's the problem with the stratolites. These are huge balloons. If there were stratolites all over the place taking images of the Earth, then we could see them with our P900, P1000. And I'm not saying that they're not out there, but they're certainly not the number that are needed. And one of the things that you weren't taking into account is that if you're using so few high altitude balloons to get, our planet is huge. I'm sorry guys, but your numbers did not add up at all. But even if you could get those balloons at super high altitudes, but see now if you're going to create images like you can get from Himawari that can just look down at the whole disk, you guys didn't think about this, but now you have all these weird perspective effects. So now you got to correct for all this distorted perspective because the clouds are going to kind of go away. Do you guys even well, I'm talking to flat earthers here. Of course you don't understand perspective. But you would need just a ridiculous amount of computing power to restore the correct perspective at these altitudes. But there's other complications with balloons as well too. Because the radar systems are very heavy and the imaging, so this would require, and again, the stratolites, they're very big balloons. It does require a very large balloon. And if we had a lot of these out there, people would be seeing them with their cameras and telescopes, but there's just not that many up there. And it's really interesting, these balloon companies, best case scenario, they all state very clearly that they complement existing satellites. They cannot replace them. So they're admitting that the weather and observation satellites do exist. Again, this is not good, guys. And then where are the ships to launch them over the sea in the maintenance? But the bottom line here is satellites just work better. So why would they spend all this money to put all these stratolite balloons around the world to try to create the images of the Earth, where satellites just do it a lot better? It's just, that's why they're not using balloons as much as they use satellites, especially for imaging. Okay, so I just want to kind of show how these guys don't understand science. Let's just hear a little clip from Jaron talking about GPS, because it does kind of relate to what we're talking about, because he doesn't understand frequency bands, like the frequencies, that are needed for the different types of cloud densities, the frequencies that are needed to image the Earth at night. So let's just hear Jaron here, and we'll debunk what he has to say about GPS.
I've never understood this whole GPS is using satellite data anyway. Wouldn't the speed of light change as per the weather conditions? Meaning if I'm on Earth and I'm needing to get my GPS location and it's so sensitive to everything, then how do they know what the speed of light is sending a data from a 22,000 mile satellite to my phone. Wouldn't that be, if there's clouds above me, wouldn't that make the light slow down a little bit?
Okay, so Jaron doesn't understand signals here. And now, don't you think these GPS companies would figure this out? That there are frequency windows to where, and they choose specific frequencies in these GPS signals so that weather does not interfere with them. So no, Jaron, it doesn't slow the signal down. And here's a link right here that talks about this, because there's a window in the weather as far as the signal propagation is concerned. And here's a link, Jaron, look it up yourself if you want to learn. Okay, so not only does Jaron not get GPS, he doesn't get the geostationary here either. Let's hear what Jaron has to say.
What picture is Himawari 8 and 9? Himawari 8 and 9 are both stationary. So he was able to differentiate between satellites in space and stars.
Very beautiful image.
Where? You're not talking about these moving things, I hope, because they're not moving. Isn't it geostationary?
Yeah, Jaron thought he had a big gotcha there, but what he doesn't understand is, Jaron, notice that the stars are all still right here. How could that possibly be? Well, because Wolfie is tracking the stars, so his camera's moving with the stars. So anything that's stationary is going to look like it's moving. So yes, you're right, Jaron. Himawari 8 and 9 are geostationary, but because Wolfie was tracking the background stars, they appear to be moving. And this is also another important point, is that you can actually, as Wolfie did, track Himawari 8 and 9, and they're going to be right where Himawari 8 and 9 are supposed to be. And if you, as we're going to look at here in a minute, if you want to build your own antenna to point at Himawari 8 and 9, you can download these images yourself, which gets into what I talked about from the Thought Emporium from my last video. And to me, this is just the dagger. I mean, because anybody can download these images themselves if they're motivated enough to build an antenna and to do it. And let's just hear what Jaron has to say, because he did say he wanted to see that. You know, he was a little bit of incredulity there, but he definitely was interested. And let's hear what he has to say here.
Yeah, so are they saying that dude went out in his backyard and got that final colored image product from the sky signal?
I think that's what he's saying.
What?
I want to see that. I mean, show me that then. Or don't just claim that happens and then not be able to ever show it. I want to see it. That would be huge information. If we can go outside and hook up a satellite and point it to the sky and then you're going to give me a picture of the Earth, I want to see that.
Yeah, and again, Jaron, you can see that. And I'm going to put some links here where you can, on how to build your own system and again, here in the Western Hemisphere, it would be GOES 16, 17. But the Thought Emporium did this, and of course I showed the video, and I'll put a link to the full video here. But absolutely you can, and the thing, and I think someone in the comments was saying, oh, they just are pulling it from the ground stations. No, the Thought Emporium was pointing their antenna directly at GOES, at the time GOES 17 wasn't activated. And they weren't getting any images, and they're close together, right? So these antennas have to be pointed just right. And when they adjusted their antenna to get it right to GOES 16, then the images started coming in. So they're pointing it at the satellites, guys. They're not getting these images from any ground station. Again, I'm going to put some links here where you can look at how to build. In fact, Walter Bislin has a good page on this as well. I'll put a link to his page here too. And let's hack it. This is a whole little ebook on how to do this. And the other one here is basically Thought Emporium, a couple of videos they did, but there's a little extra information here on how you can build your own system. Again, very detailed. And they show some of the images they were able to download. So again, if you're really motivated, like Thought Emporium, you can build your own antenna and you can download this data. And watch my last video. I gave a really nice clip from that video. Build one of these satellites, hook them up, or find someone to help you out that has the technical know-how to do so. So anyway, that's all that I have here. And I just want to conclude by saying, to me, the Himawari-8, the GOES 16, 17, these are some of our best pieces of evidence that we live on a sphere. And with the Artemis 1 successful mission, almost coming to a close now, we have many more images of our whole Earth from space. And I'm going to do another video. I've done several videos on Artemis, but I got one more really good one coming that really ties it all together and confirms that space is real, these images are real, and even ties it into the GOES 16 and 17 here. So as I close here, I just want to show you this nice image of the Earth from space from Artemis, right next to the GOES 16. And you can see, look at the cloud formations. They match. I've done a whole video on this, but it just ties in so nicely to show that the images from the GOES 16 are matching perfectly the images from Artemis. And it's just a great confirmation that this space mission is real, that GOES 16, 17 is real, that Himawari-8 is real, and we live on a sphere. So thanks again for watching. I hope you enjoyed this video. Do like and do leave some comments, and I would love to hear what you think, and have a really great night.